students, welcome to today's tutorial on product resolution techniques. So today we will see about crystallization process, important parameters which are to be considered which has a major impact on crystallization, types of crystallizers like tank crystallizer, scrape surface crystallizer and circulating magma evaporator crystallizer. So these three types of crystallizers are commonly used in industry, so we'll have an insight on all these three types of crystallizers. So in yesterday's lecture, we have seen the crystallization process, how it is carried about. So based on crystallization, we have different types of equipments and they are classified under two categories. So the first categorization is known as crystallizers and second categorization is known as evaporators. So both of these are used for crystallization process. So when you have a substance whose solubility is going to increase with increase in temperature and then you're creating a supersaturation condition and then cooling the mother liquor. So the liquor is then cooled so that crystals are formed. These type of equipments are called as crystallizers. So these are the categorization, the first category. And second category, when you have certain substance whose solubility is not going to change much with temperature. But then you have to create supersaturation by concentrating the liquor. So once you concentrate the liquor, you can saturate it, supersaturate it, and this is carried about by evaporating. So once you evaporate the solution, then you will have concentrated solution which can be later cooled down to form the crystals. So these kind of equipments are called as evaporators. And in the third type, you have a combination. So in this, you have both evaporation and cooling, which can be done effectively. So basically, these are the two types of systems that we have, crystallizers and evaporators. So this graph gives you an idea about what I was telling you. So y-axis is nothing but solubility and x-axis, as you can see, is temperature. So as we already discussed, sodium chloride, the solubility is not going to increase much with temperature. That is what you can see. The line is almost straight. So that means as temperature increases, the solubility is not going to increase much. So that is why in this case, you will have to evaporate the solution. You will have to evaporate it to make it more concentrated so that you create a supersaturation condition and then you cool down the mother liquor so that crystals are formed within the system. So this works on the second system that we saw, that is evaporators. So this crystallization process, as we already saw, there are two modes, either the batch mode or the continuous mode. So you can work in any of these systems. We have already discussed this in the last lecture. So coming to the parameters to be considered. So yield is one important parameter that we have to keep in mind. So once you use a particular crystallizer system, the final yield that you get from that system plays a major role. So because finally it is in a company, yield is the final thing for them. So once you get a better yield from one system, definitely they'll go for that system because finally they can market it in a better way and get more profit from that system. So yield is one important parameter that we have to consider. Apart from yield, heat is also one important thing because once you heat the solution, in the case of evaporator as we saw, you are creating a supersaturation condition, and once you create that supersaturation condition, you can try to develop more crystals out of the system. So heating is also one important parameter that we have to consider. Apart from this, even purity of crystals plays a major role because finally, your crystals has to be the purest form. So crystallization technique as it is will try to help you in producing pure crystals in the system, and this because it is a polishing step, the purity plays a major role here because in the crystal bottles that we have, the chemical bottles, you might have seen 99% pure, 95% pure. So that in turn tells you the purity of the crystals present in the sample. Apart from purity, even size and shape plays a major role and that also becomes a parameter for us, and even the size distribution also plays a major role here. So coming to the types of crystallizers, as I told you, we have three different types of crystallizers. One is tank crystallizer, second one is the scrape surface crystallizer, and the third one is circulating magma evaporator crystallizer. So we'll study all these three crystallizers which are used in industrial scale in detail. So coming to the first type, that is the tank crystallizer. So this is a image showing you the working of a tank crystallizer. So as you can see, it is an open tank kind of system, a trough kind of system. As you can see, there is a double wall jacket that is basically to control the temperature, but controlling the temperature is not very easy in this system as it is an open system there. And within this open trough, you introduce the supersaturated liquid inside it where you want to produce crystals out of it. And then, as you know, since the trough is open, the temperature is going to fall down, and as temperature falls down, the liquid is going to get converted into crystals. So these crystals can be collected later How to collect it? You can see down there is a drain system there. So through the drain system, all the mother liquor can be collected separately, and then you can separate the crystals from the system. So this is how the tank crystallizer works. So here you have an open system. So there are problems associated with controlling the temperature and other aspects. So as we studied, it is a batch operation, and it can be open trough system with varied size. So based on how much volume or sample you have, the size of these crystallizers can change. And then to introduce or to initiate the process of crystallization, we can introduce something called as seeding material. So this we have already discussed in the last lecture. So please keep that in mind. The seeding material acts as a nucleus over which your crystals start forming, and that is how the final crystals are developed. So that is how this kind of system works. So the disadvantage of this system is high cooling rate at the initial stage of process. So cooling rate cannot be controlled easily here since it is an open system. So the cooling rate initially will be high and then it decreases. So that is how this becomes a problem sometimes. And the quality of crystals that you get in this system are poor when compared to other systems that we will see in the next slides. And coming to the problems of scaling. So since the cooling rate is not uniform, there's a chance of scale forming within the system, and once scale is formed, you know the heat transfer coefficient or heat transfer is going to hamper, and once that happens, definitely your shape, your quality of the crystals is going to get deteriorated. So that is why this becomes an important task, or it is the disadvantage of the system. Apart from that, the applications of this are basically for crystallization of antibiotics and other bioproducts of moderate or low molecular weight. So to overcome these issues, they have come up with next type of crystallizer called as the scrape surface crystallizer. So here you can see this is a more controlled system compared to the previous type where it was an open trough, but here we have a controlled kind of system here which is completely closed. So your heat transfer and other problems, issues which we saw in the previous type can be nullified here. So here you have a motor system, and you can see an agitator to which you have the blades which are attached to it, and these blades will be continuously rotating so that whatever crystals are attaching to the wall which is forming the scales on the surface, the heat transfer decrease is happening, so that is avoided. So once you have the scraping systems, whatever is attached to the wall of the container, it falls back into the system, and that is how it forms crystals again. So the surface is clean, that means heat transfer is better, and that is how your crystal formation is better in this system. So here also finally you can drain off the mother liquor and you can collect the liquor from the bottom, and the crystals can be separated finally from the system. So this is a double jacketed cooling trough as we saw the construction of this, and we saw already that there is an agitator which helps in connecting it to the scraper, which allows in separation of the substance that is attached to the wall into the inner side. Okay, so it gets suspended again. So once it is suspended, there's a chance of crystal formation, and because of this system, there's good heat transfer coefficient that is happening, and we get wide range of crystal size distributions within the system. So the third type of system that we have is circulating magma evaporator crystallizer. So in this case, circulating magma. Why it is called circulating magma? Because here the liquid is heated. The feed system that you introduce is heated in a heat exchanger, and that is introduced within the system. That is the heart of the system in the center part, which is, you can see, that is the heart of the system. So you're introducing there, because the hot liquid is introduced into the system and it is continuously circulated back. So it is a continuous movement of this hot material within the system. The name magma is given here. Okay, so this is used in case you have a high rate of evaporation. When you have high rate of evaporation and you have certain materials with you which are highly viscous and which can form scale in the system, then the first two systems that we saw may not be very useful to use, because we know scale formation creates a problem there. And when you have certain solutions with inverted solubility, this type of system is commonly used. So what is inverted solubility? Before that, you should know what is solubility. So solubility is nothing but increase in concentration or increase amount of solute, the amount of solute that can solubilize in given amount of solvent. So if solubility increases with increase in temperature, then that is normal solubility. But inverted solubility means your solubility is going to decrease with increase in temperature. So in such conditions, when you have decreased solubility with increase in temperature, this type of crystallization, that is the circulating magma type of system, is commonly used. Okay, so this is the best choice when you have inverted solubility. That is, your solubility is going to decrease with increase in temperature. So that is what is exploited here. We're trying to decrease the solubility of the material by increasing the temperature. That is why we have the heat exchanger system here. Okay. So first you will introduce your feed. You will use a pump for lifting it up to the heat exchanger. So in the heat exchanger it is heated up. And once it is heated up, the heated liquid that is called as the magma is introduced into the heart of the system, the center system there. And there what happens? Your hot liquid is coming there and it is going to get cooled in that system. So once it gets cooled, your crystal formation happens again. And that crystals can be separated finally. And there is a demister system there. So that is to nullify the losses in the system. So there the vapors are collected and through the side system there, as you can see, the vapors are sent out into the system to the exhaust. Okay, as you can see there. So that is how this circulating magma type of system works. So in case of inverted solubility, as we have seen, this plays a very important role. And suspension of liquid known as magma, whatever we saw, is circulating out of the heat exchanger throughout the circulated pipe. That is why the name circulating magma type of system is given to this particular type of evaporator system. So we saw 3 different types of systems here. The first system that we saw was tank crystallizer, which was an open tank system where we had a lot of issues there, scaling problems and heat transfer problems and other things. So to avoid that, we saw the second type, that is the the scrape surface type of crystallizer, where we have encountered most of the problems which we have seen in tank crystallizer. And the third type of system we saw when there was certain liquids with inverted solubility, that is the circulating magma type of evaporator crystallizer. So these are the 3 important crystallizers that we have for today's lecture. Thank you for watching, guys. Do subscribe the channel for more updates.